Hello, Algebra 2. This is the first day of Chapter 10. The first lesson is 10.1, Sample Space and Probability. The essential question is, how can you list the possible outcomes in the sample space of an experiment? So we have a couple of vocab words here. So probability of the experiment is an action or a trial that has varying results. The outcomes are the varying results from the probability of the experiment. So for example, rolling a number cube, the outcomes are a 1, 2, 3, 4, 5, or 6. An event is the collection of one or more outcomes. So for instance, rolling a number cube or flipping a coin, and the sample space is the set of all possible outcomes. So this first day we work a lot with sample space. So for example 1, you flip a coin and roll a 6-sided die. How many possible outcomes are in the sample space? List the possible outcomes. So some of these can get pretty long. This one's not too bad. I think 3 in the assignment is pretty long, and I do believe that we took that one out. So here it says you flip a coin, which remember there are tails or heads, and then you roll a number die. So you could, for instance, get heads and then a number die get a 1. Or you could get heads and get a 2. Heads 3, heads 4, heads 5, heads 6. Or you could flip a coin. You could still get 1, 2, 3, 4, 5, 6 on a number cube, but get tails. So tails with a 1, tails with a 2, tails 3, 4, 5, and 6. So these are all of the possible outcomes that there are in the sample space here. So it says list the possible outcomes, and I always like to say that there are 12 possible outcomes. Okay, so we do have some problems here where they talk about the likelihood of something occurring. It's impossible if something has a probability of happening 0% of the time. So you can just kind of go through this. Unlikely is like around that 25% range or a quarter of the time. Equally likely to happen or not to happen is that 50-50 chance. Likely that it's going to happen is that 75% range, and then certain it's going to happen is 100% of the time. Theoretical probability, so we're going to talk about experimental and theoretical probability. The difference between the two, theoretical probability is the actual probability. So it's not like you're going to go through and flip a coin and go through that. That's an experiment. What they want is the theoretical probability. You get a 50-50 chance that you're going to get heads or tails with flipping a coin. So it's the actual probability. Just know that you talk about the number of favorable outcomes over total. So the number that you're talking about, and this is huge, that it's always over that total outcome. And in some of these problems, you're going to have to actually write out and figure out what that sample space is before you can do this. So in this case, we have a student taking a quiz, randomly guessing the answers to 4 true or false questions. What is the probability of the student guessing exactly 2 correct answers? So the first thing that I want you to do is I want you to list out all of the possible outcomes. So first of all, the student could get 4 incorrect true or false questions. They could also get 3 incorrect and 1 correct. Now, this is showing that question 4 is incorrect, but it might have been question 3 that was incorrect, or question 2, or sorry, correct, I should say, that was correct, or question 1 that was correct. So you go through all of those possible outcomes for that, and then you've got where you have 2 incorrect and 2 correct. Now this could go quite a few different ways. So it could go incorrect, and then I'm just going to kind of go through the chances with the incorrect being first. Could have 2 correct in the middle and 1 incorrect at the end. And then you also have your possibilities of correct being first. So correct, correct. And then correct, incorrect, correct, incorrect. I do believe I have all of the possible outcomes for that one being true. And then you've got just like having 3 incorrect and 1 correct, you could do the same thing with correct and incorrect. So I just did the same thing that I did with the 3 incorrect and then with the correct that time. And then the last one is having all 4 of them correct. Okay, so the total possible outcomes. So let's just look at each of these. There's 1 possible for all 4 being incorrect. There are 4 possible for 3 being incorrect, 6 possible for 2 and 2, 4 for 3 being correct, and 1 for all 4 being correct. So if you look at the total outcomes, there are 16. So they want, so the total is 16. Now let's go back up to what they're asking for. It says, what is the probability that the student guessing exactly 2 correct? So if you look at this first red column, that was all 3 incorrect. And then this one was only 1 correct. This is the column where you've got 2 correct answers. So you want to say, so 2 correct, we're just going to talk about. There are 6 total. So to find the probability of this, you are going to take 6 out of 16 total possible outcomes. You get 0.375. I like to look at it as a percent, so 37.5% that they'll get 2 correct. Okay, so we have what's called the complement, okay? So if the probability of something happening was 25% of the time, the complement of that is the probability of this not happening. So not A, that's the complement. Or in other words, they call it probability of the complement of A with like a little bar above it. And what's not A is like taking 100% minus that 25%, which would be 75%. So the complement of 25% is 75%. So sometimes it's easier to find the complement to figure out what the probability of something is. So for instance here, they give us all of the possible outcomes for rolling a dice. So it says when 2 6-sided dice are rolled, there are 36 possible outcomes as shown. Find the probability of each event. So for part A, the sum is not 6. So for instance, let's find the probability that the sum is 6. So let's count up all the ones where the sum is 6. So when we look at this, we've got 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 1 and 5. So all of these give us a sum of 6, and there are 1, 2, 3, 4, 5 possible outcomes. So that means that that's 5 out of 36. But we want that the sum is not 6. So instead of counting up all of these other ones, let's find the probability that the sum is not 6. So instead, we want all of the remainder here. Instead of counting them up, there's a possibility of 36 outcomes, and 5 of them were the sum of 6. So you're going to take 36 minus 5, and that gives you 31 out of 36. Go ahead and figure out that decimal. You should get 86.1% is of the sum not being 6, which makes sense if you look at what's red here and what would be remaining after that. Okay, so for this next one, it says the sum is less than or equal to 9. So it is easier to find that the probability that the sum, so not less than would mean, so we're going to say not less than or equal to would mean basically anything that is bigger than 9. Okay. So anything that is bigger than 9. So let's go through this again. I'm going to recircle. So let's start over here. So larger than 9 are all of these, and it's not larger than 9 or equal to. Now 6 plus 3, that gives us 9. We want anything larger than 9. 5 plus 4, that's 9. We don't want that. 5 plus 4. And then we have 6 plus 4 is bigger because that gives us 10. But this is all the outcomes that are bigger than 9. 1, 2, 3, 4, 5, 6. So 6 out of 36 are bigger than 9. So what would mean not, so basically the opposite of this would be the sum is less than or equal to. So the probability that the sum is less than or equal to 9. Well, we've already found out that 6 of them are greater than 9, so less than or equal to 9. We would take 36 outcomes minus the 6 that we talked about before and we found. So we have 30 out of 36, giving us a probability of 83.3%. So this would be an instance where finding the complement would be a lot easier because we were only talking about 5 or 6 instead of coming up with 30 or 31 of them. It's a lot easier to count the 5 or the 6 and then to take the complement.